Good afternoon, folks. This is your recording for Wednesday, May 16th. If you would please go ahead and fill in this first portion, what is a perfect square, and list your first 20 perfect squares. Thank you. So if you are not done with that, go ahead and pause the video, and when you're ready to resume, go ahead and push play. Today, we are going to spend another day dividing radicals. So when you are multiplying and dividing radicals, you do not need like radicals in order to divide. You can multiply and divide anything you want. When dividing, remember you cannot leave a radical in the denominator. Any final answer cannot have a square root in the bottom. In order to fix this, you must do something called rationalizing. This means multiplying the numerator and the denominator by the radical on the bottom, and then simplify it. So if I take a look at number 1 and you see my directions say to simplify, I cannot leave that radical 5 down there like that. I have to rationalize it, which means I'm going to multiply the numerator and the denominator by radical 5. So in the numerator, the 3 is not under the radical, but the 5 is. So this will stay as 3 radical 5. In the denominator, both 5s are underneath the radicals. So when we multiply them, you get 25. Well, 25 is a perfect square, so we're going to leave the 3 radical 5 up top, and in the bottom, the square root of 25 is 5. Now, folks, you cannot break down the square root of 5. There's nothing that will divide into 5. And if you look, I'm going to look at the 3 that's out front and the 5 that's on bottom. I cannot reduce those, so this will be my final answer. For number 2, now we have a fraction under the radical. Well, if I'm going to do the square root of a fraction, that means I take the square root of the top and the square root of the bottom. Okay, now remember, we're allowed to have a square root in the numerator. I am not allowed to have a square root in the denominator. So I'm going to go ahead and multiply the numerator and the denominator. So it'll look like that. Both the 7 and the 8 in the numerator are under the radical, so we are going to multiply them. Both the 8's in the denominators are also under the radicals, so we will multiply them. Now, I know that the square root of 64 is just 8, so that's my denominator. 56, though, can be broken down, so that's what we need to do next. So let's split 56 up. 56 is 7 times 8. 7 is done. 8 is 2 times 4, and the 4 is 2 times 2. So it looks like I have a pair of 2's that are going to come out. And underneath, I will still have a 7 and a 2. So if we take a look at this, you see the 2 in the numerator out front, and you see the 8 in the denominator. These two right here can be reduced. 2 over 8 is 1/4. So you don't have to put the 1 out front, or you can, it doesn't matter. So 7 times 2, we have the square root of 14. And remember that 2 over 8 I reduced to 1/4, so I'm going to now have a 4 on the bottom. And again, if you wanted to, you can put that 1 out front. All right, number 3. Problem here is that we have that 24 in the denominator under a square root. So we got to multiply the top and bottom by that. The 9 is outside of the radical in the numerator, so that 9 stays outside. Underneath, we have 3 times 24, so that needs to go ahead and be multiplied, and that will stay underneath the radical. We get 72. On the bottom, 24 squared is 576, but 576 is a perfect square. It's just 24. Now, we need to keep that 9 that's out front, and we need to break down that 72. 72 splits into 3 times 24. 24 splits into 3 times 8. 8 splits into 2 times 4. And 4 splits into 2 times 2. So remember, we already had that 9 that was out there to begin with. I have a pair of 3s. I have a pair of 2s. And I still have a 2 left underneath. So if I multiply all that, I get 54 radical 2 over 24. Now, I can reduce the 54 and the 24. Both of those things are divisible by, let's see here. Both of those things are divisible by 6. 54 divided by 6 is 9. Whoops. Is 9. 24 divided by 6 is 4. So that will be my final answer. The common mistake, folks, is not to reduce it at the end. Okay, now if you look at both of these are both under the radical to begin with. So I'm going to go ahead and multiply 3 and 3/7 and 2 and 1/3. And under the radical, I now have an 8. Now notice I have no fraction bar or anything left. So this becomes a regular simplifying problem. All I need to do is break this down and see, whoops, I don't want to circle that, and see what we can get pairs of to come out of here. So it looks like a 2 is going to come out, and there will be a 2 left underneath. So there was no rationalizing to do in that problem. The fractions just kind of canceled out. All right, moving on to the back here. Okay, that 6 is going to stay on the outside. I need to multiply by radical 35 over radical 35. The 7 and the 35 are both under the radical, so when we multiply that, we get a 245 under the radical. And in the denominator, that's going to be a 35 times a 35, which is 35 squared. And remember, that is under the radical, and that is a perfect square. You get 35 when you take the square root of that. Okay, now we need to go ahead and simplify that 245. So 245 breaks down into 5 times 49, and 49 is 7 times 7. So I had a 6 that was already out there. Looks like a pair of 7s make it out, and we still have a 5 left underneath. So 6 times that 7 is 42 radical 5 over 35. Now again, remember, we have to try and reduce this. 42 and 35 are both divisible by 7. So this will be 6 radical 5 over 5. When you divide 42 by 7, you get 6. When you divide 35 by 7, you get 5. Okay, number 6 here. Looks like I've got a radical on the bottom I needed to get rid of, so I need to rationalize it. We're going to multiply by the square root of 39 over the square root of 39. Now, folks, in the denominator, the whole point here is that's going to be a 39 times 39, which is 39 squared, which means that's going to be a perfect square, which means in the denominator, I'm just going to get a 39. Okay, there's no more square root there. In the numerator, I've got that 48 times the 39, which is going to be a relatively large number. I have 1872. And there was a 5 out front to begin with. So I need to go ahead and try and simplify the 1872. Let's see what we can get that to divide by. Looks like that will divide by 4. 4 times 468. The 468 will divide by 4 again. That's 4 times 117. And how about the 117? That's divisible by 9. And that 13 will not break down any further. So now, I had the 5 out there to start with. It looks like I've got a pair of 2s, a pair of 2s. I've also got a pair of 3s, and I've got a 13 left underneath there. So when you multiply all that, it looks like that should give you 60. Radical 13 over 39. Now, both 60 and 39 are divisible by 3, so I'm going to reduce this. 60 divided by 3 is 20, and 39 divided by 3 is 13. So it's going to look something like that. Okay, next two aren't too bad because you see your radicals there. They're over a fraction, which means I'm going to take the square root of the numerator and the square root of the denominator. Well, you'll notice the denominator is a perfect square. You'll also notice that 3 on the outside is not under a radical. So right now, after I take that perfect square, it looks like that. Please notice the 3 over 3 will cancel. So all I'm left with is that 48 under the radical, which means I'm going to go ahead and try and break that down. 48 is 16 times 3, and 16 is 4 times 4. So when all is said and done, that 48 breaks down like this. So I've got a pair of 2's and a pair of 2's, and I've got a 3 left underneath, which leaves me a final answer of 4 radical 3. Okay, same thing's going to happen over here in number 8. That 7 is outside. When we take the square root of a fraction, we do the square root of the numerator, the square root of the denominator. So you'll notice that in the denominator we have a perfect square. The square root of 49 is 7, which will cancel with the 7 in the numerator. So all I need to do is break down 40 to simplify. So it looks like I've got a pair of 2's, and I'm going to have a 2 and a 5 left underneath that had no pairs, and 2 radical 10 will be my final answer. Okay, so next section, I just didn't want you to forget how to multiply these things. So remember when we multiply the coefficients out front, we multiply underneath the radical, and then we're going to break down that radical. When we do that, we already have a 12 out front. We got a pair of 5's, and we have a 3 that's going to be left underneath. So 12 times that 5 is 60 radical 3. Do the same thing here in number 10. When you multiply the coefficients, you get negative 12. When you multiply under the radicals, you get 25. Well, the square root of 25 is just 5. It's a perfect square. Please notice there is no more square root in this problem. You multiply them together, and you get a final answer of negative 60. All right, so multiply these guys. They are fractions, but they are both under the radical. So if you use your calculator and multiply them together, you will just get a 9. Well, 9 is a perfect square, so the square root of 9 is 3. No more radical over that 3. Finally here, these two are both under the radical, so I can go ahead and multiply them. If I'm going to break down 180, I can go 18 and 10. Break down that 18. It looks something like this. There was nothing out front to begin with. I do have a pair of 3's. I do have a pair of 2's and a 5 left underneath, which will leave me with 6 square root of 5. Okay, folks, so that is your second day on dividing. Remember that you cannot have a radical in the bottom of a fraction. You have to rationalize that. Okay, your homework is a half worksheet that Mrs. Terrell will pass out to you when you're done with this, or if you're in Mr. Kamaleski's room, Mr. Kamaleski has those at his desk. Thank you. We'll see you tomorrow.